Hello, welcome to Dream Academy. I am here to teach you the control system, which is very much easy and important subject as well for your gate examination. So, control system actually deals with the designing of any system, controlling a system. It talks about the transfer function of any system. Transfer function means the response of the system with respect to the input given to the system. Then it deals with the stability conditions, then the time domain analysis, like first order system, second order system, rise time, peak time, settling time, all of these things. Then it's frequency domain analysis. In frequency domain analysis, we talk about the polar plot, Bode plot, Nyquist plot. All of these are frequency domain analysis technique. In this technique, we always use to find if the system is stable or not. All of these are used to find if the system is stable or not. Then we move into another topic, that is industrial controller and compensator. Then we will go to some important topic which is again important for the gate examination, that is the modern control theory. That actually deals with non-linear input output, state transition matrix, and all of these things. We will talk about these things by chapter by chapter. Okay, so this series is all about your control system, and so just start the topic. So today is the first topic about the control system. Actually, today I will not teach you actual control system. Today I will teach you something which is needed for the control system, which is actually needed to take the grip um, to take the grip about the subject. Okay, so that means the tools we actually need to do good in this subject. Okay, so first of all, I am telling you some important mathematical tools which are actually needed to do good in the control system subject. Okay, so the important mathematical tools for control system. Okay, so first of all, the differential equation. Then our Laplace transformation, and your inverse Laplace transform. Okay, then your principle of arguments, then your basic matrix operations. Okay, so these four are actually the most needed mathematical tools, which are actually very important for you to know, to take the grip in this subject, or you can say to further proceed in this subject, or you can say to do good in this control system subject. Okay, so I assume that you must know this subject very well. If you don't have enough confidence in these four mathematical tools, then please be ready with these four mathematical tools. Then just start your control system preparation, because without these four without these four mathematical tools you can't do very good in this in control system. Okay, so just be ready with these four mathematical tools. So now I am assuming that you all know about these four um, mathematical tools. So I am just starting the basic things of the control system. Okay, so first of all, any system, first of all we want to know what is actually control system. We can say there can be two type of system. One is controlled system, another is uncontrolled system. Another is uncontrolled system, the system which we can't control. The system can only decide its output, its nature, its behavior. The system can only mm, define that. And in case of controlled system, we can control the output. We can control the output and get the output which we actually desire to get. Okay, so our point of interest is this type of system, because our subject is control system, so we are only bothered about the system which we can control, the system which can be controllable, that is the controlled system. And another system which is uncontrolled, that is not actually about our concern, so this goes to the hell. And there is two type of controlled system. One is your manual control system, and your automatic control system. Automatic control system. This manual control system, we can say it as open loop system. Why it is said as open loop system, I will tell you later. And this automatic control system is also known as closed loop system. Okay, so manual control system. Okay, so manual control system, which actually, why it is known as open loop system, because here I am saying that this is my system, okay, this is my system, which I am denoting as G. Okay, I am denoting as G. Okay, and this is my input, this is my output. Okay, so if I change the output, I will get the change in the, if I change the input, I will get the change in the output. Okay, so if I want to change any output, I must have changed the input. There is no automatic system, that system is always manual. That means I have to change the input, then only I will get the change in the output. That is the open loop system or the manual control system. That means I have to change the input manually, then only I will get the change in the output. Okay, I have to change the input manually, then only I will get the change in my output. That means this is known as our manual control system or our open loop system. Why this is open loop system? Because there is no loop. There is no loop, only open. There is no loop. So that is why we also known this type of manual control system as our open loop system. Okay. So any example about the open loop system? We can say that is our electric fans, electric fans. Okay, there is no sensors in the electric fans. Okay, we have a regulator. We want more speed, we use the regulator to increase the speed. We want less speed, we use the regulator to decrease the speed. Okay, so this is the example of our mm, our open loop system. Then another type of system, that is the automatic control system or closed loop system. Then I am again saying this is my system. This is denoting, I am denoting as G. And here this is a automatic control system. So this system requires a sensor which I am denoting as H. This is my sensor. Okay, this is my sensor. This is my sensor. This is my system, which is denoted by G. This is my sensor, which is actually used to sense the output and collect the data and feedback it to the input terminal, so that the system can realize if I am getting the output which I actually needed or I am not getting. Then according to the sensor output, the system actually decides if it have to increase the value of the input or it have to decrease the value of input. Okay, so this is my output is sensing or sensed by the sensor, and that data is sent to the input terminal. Then that is compared using a comparator. Here is a comparator is over here, which is known as the brain of the system. Any type of automatic control system always has a brain. This brain is our comparator. That means that sensor output and this input, we have that this brain compares, and after comparing it actually used to decide that if the input have to be decreased or increased to get my desired output. So this type of control system is automatically controlled. It is automatically controlled to get the desired output. That is why it is actually known as automatic control system. And as there is a closed loop in this type of system, so this is known as closed loop system. Okay, so any type of closed loop system always has two type of feedback. This is feedback. I am feeding back the sensor output to the input terminal. This feedback can be two types: positive feedback and negative feedback. Okay, so we always use negative feedback for our system to make our system stable. The positive feedback always makes our system unstable. Why this makes our system unstable? Why negative feedback makes our system stable? Why negative feedback is always used in our system, I will tell you later. Okay, for this time you only know that this negative feedback always used to make our system is stable. And anywhere in this world, anywhere, any physical system always using the negative feedback to make the system stable, because the positive feedback always makes the system unstable. Any physical example about the positive feedback, that is, there is two only use about the positive feedback, that is Smith trigger and our oscillator. These two things only use the positive feedback concept. Okay, so I am not moving any further, any deeper about these two Smith trigger and oscillator, because this is all of your analog things. So I am not going to teach you the analog. I am here to teach you the control system. So I am not actually going deeper in this concept. I am only saying that positive feedback is actually used in case of Smith trigger and oscillator. You take this as only a example. Okay, and negative feedback is used when our system is stable. A negative feedback is used because it makes our system stable, and anywhere in the world any system is using the negative feedback. Positive feedback is not used at all in any system. Any stable system is using negative feedback. Okay, so why negative feedback is stable, why positive feedback makes the system unstable, I will tell you later. Just uh, just be patient, just hold your patience and watch our series. I will tell you why this is stable and why this makes our system unstable. Okay, so now I will tell you about some basic functions which will which we will used which we will use in our control system, and we will give these functions as input in our system, and we will check how my output behavior is. So some basic functions. First of all, my basic function is the impulse function. Okay, so impulse function is the function which have the magnitude or value in only one instant of time. Here I am taking that the only instant is t is equal to 0, and it has infinite magnitude or infinite value in that time instant t is equal to 0. So impulse function is denoted by delta of t. Delta of t is equal to infinity at t is equal to 0 and 0 elsewhere. Okay, so now we can say this impulse function as unit impulse function when the area under the impulse is equal to 1, then that is known as unit impulse. This is minus infinity to plus infinity. That means the overall area under this impulse is 1, then only we can say it as impulse function. Okay, so now our second function is step function. Step function is the function which have value only after a particular time period, and it is actually constant after that time period. That means impulse is a shock. Like you are giving the input, and only at that instant you are removing that input. That is like a shock. This is my impulse. At a particular time you are giving the input, and that particular instant you are taking out the input. That is like a shock. This is my impulse. Okay, and the step function is a constant. You are giving the input, and you are not removing that input for a infinite instant of time. That means you are giving the input and you are not removing the input for a infinite instant of time. Okay, so our step function is denoted as u of t, and u of t is equal to 1 when t is equal to 0 to infinity and 0 elsewhere. That means just after 0 you are giving the input as 1 and you are not removing the input up to the infinity. Just after 0 you are giving the input and you are not removing the input up to infinity instance of time, Okay, so this is our step function. When this magnitude of the function is 1, then it is known as unit step. When this is not 1, this is something else, then that is only step. Okay, so our third function is ramp function. Ramp function, the here this is t, this is u of t, here this is t, this is ramp function is denoted as r of t. The function is denoted as this. Okay, the function is denoted as this. Ramp function is denoted as r of t. R of t is equal to t when t is equal to 0 to infinite and 0 elsewhere. Okay, so now when this, and another thing, when this slope of this ramp is 1, that means this slope y by dy by dx is equal to 1, then this is known as unit ramp, and otherwise this is known as only ramp. Okay, only ramp function. If the slope is 1, then that is unit ramp function. Okay, then the fourth function, that is my parabolic function. Parabolic function is a non-linear function. This is my t, this is p of t, which is denoted by parabolic function. This is acting like this. This parabolic function p of t is equal to t square by 2, and that is from t is equal to 0 to infinity, and that is 0 elsewhere. Sorry, I guess you have not able to see the writing because of the camera, but don't worry, here this is p of t. Parabolic function is denoted by p of t. P of t is t square by 2 when the time is from 0 to infinity and is equal to 0 elsewhere. That means rather than t is equal to 0 to infinity, the function value is 0. This is known as our parabolic function. Okay, and now again, so these four functions, impulse function, my step function, my ramp function, my parabolic function, these four functions are basic functions which are needed for our control system. We will apply this function as the input in any system, and we will watch how my system output or system response varies. Okay, so now again, another important thing, if you integrate this del of t, you will get step function. Again, if you will integrate this unit step or step function, you will get ramp function. If again you will integrate, you will get parabolic function. And if you will integrate, similarly if you will derivate this parabolic function, you will get ramp function. If you derivate this ramp function, you will get step function. If you derivate this step function, you will get impulse function. Okay, so these are the important points to be remembered, because from this concept only you may get questions in the gate examination. Okay, this on this concept only. Okay, and this is an important concept. You must take care of these two important notes. You can take it as note, important note. Okay, so today's video is only about this, only up to this. So you please watch our series about the control system. I think you must get confidence in your control system. You will do good in your control system. So please, I am requesting you, or I am recommending you to be prepared, be build your confidence in these four mathematical tools. Otherwise you will not do good. You cannot do good in your control system. These four mathematical tools are the building blocks of your control system. Then again, these systems I have said you. I will say you. I will tell you why this negative feedback system makes the system stable, and why this positive feedback makes the system unstable. I will say you in the next video. So please be prepared with the four mathematical tools in the next video. Till then, take care. If you like our video, please make sure to subscribe our channel Dream Academy and share with your friends, like our videos. Okay, goodbye.